So I promised I wouldn't do live demos, but I can't help myself, sorry. So just one little quick thing here. So as I said, we also do 2D. So this is Andy on stage. I was using sight vision, following him. I had a bridge embedded here and took a snapshot, made a to-do, and now it's in Connect. So now Andy will be with us forever, or at least virtually. All right, let's switch to the presentation, because I have a lot of stuff to, so I was going to experiment with this, but the Lithuanian that it produced wasn't really good, so let's not do real-time translations this time, but this is technology that is actually available already. Speaking English, and then there are subtitles coming out in any language you choose, and you can, on your mobile device, you can actually follow my presentation in your own language. But
no, not Lithuanian. Lithuanian language is pretty, unique.
It's okay. So no thanks. Okay, and so for this presentation, I have to put in the safe harbor. So some of the stuff may or may not come in products, and some of it is just pure research or out of interest, and I'm actually showing a lot of stuff that other people are doing as well. So the content, general advances in computing, web technologies, high-speed mobile networks and IoT, advanced visualizations, machine learning, mixed reality, and last but not least, human-machine interfacing and robotics. A lot of topics. So yeah, what is the future? I think this is at least part of it, and for the construction industry. So real quick, what's happening in computing, or what has happened in the last 10 to 20 years? Our computers have become very powerful. So we have nowadays what would have been a supercomputer 20 years ago. That's now a laptop, or it even fits in your pocket. So you have really high performance machines on the edge of the cloud, which means that not everything has to go into the cloud. Some computing you can do offline on your machine. You can even do machine learning, and then you can also offload your machine or stuff to the cloud. So we kind of need to balance, and there's actually more compute power outside of the cloud than in it, but it's a balancing thing. And same thing with GPU. So I actually showed you the live demo already of the visualizer, so real-time graphics. And again, massively parallel, thousands of cores working in parallel on a task, simple tasks like rendering, 3D graphics, or machine learning. So that's the kind of capabilities we now have in our advanced phones and laptops. Then a few words about web technologies. So as I said, I started with web technologies back in '91. It was a bit smaller back then. And we have had what I would say desktop-grade applications in the browsers. So on the left upper corner, I actually have PowerPoint running in the browser while I was creating a previous version of this presentation in August. I did this similar presentation in Pittsburgh for our Tekla base camp. SketchUp in a browser, full editing in 3D, has been available for a couple of years. Trimble Locus, which is this advanced GIS city planning software, editing capabilities in 2D and 3D, everything in the browser. And while I was speaking, this video clip, it wasn't sped up. It was the Mercedes-Benz Stadium in Atlanta, where they played the Super Bowl final. 230 million individual triangles, hundreds of thousands of objects, the whole roof structure detailed to every nut and bolt. And basically, I could talk through this slide while it was loading. And here is what our customers are using. So this is Trimble Locus Cloud. They have embedded point clouds, BIM models, and existing infrastructure derived from the city model running in the browser with both 2D and 3D capability. So I have to give you some language back, so the subtitles are in Finnish. So this is how Finnish looks like. And let's just fast forward because I have a lot of stuff to show you guys. So this is the combination view of, so that was like the traditional 2D GIS, and then we can combine it with 3D photogrammetry and so on. And this is no installs, very, very fast to take into use. And the web technology is developing at a rapid pace. So progressive web apps, basically applications that you can kind of install on your phone or on your desktop. Better offline support. As I said, there are still places where you don't have a network, so you still want to have your data, and this works with the browser as well. And it's easy to move existing application, or not easy, but it's possible to move existing applications like SketchUp so that it runs completely in the browser. And just to show you the speed of things, WebVR, which is actually what I was showing outside on the Oculus Quest, so basically 3D running, VR running in the browser, that was experimental last year. Next month it will be removed from Chrome as deprecated, and WebXR will take its place. So that's the speed of web development. And we have put a lot of our core components into the web lately, including our data management technology. So the impact is that we can split up our large monolithic applications into more specialized, smaller applications. So they start up fast, you have quick access to your data, simple user interface, it's always up to date, and no installation, and works on multiple devices. And your settings are stored somewhere in the cloud, so you don't have to configure it every time you use it on a different machine. So a lot of benefits. Then high speed, and now let's see if the audio is working. Nope. Which means that I'm going to do this. I'm going to pull. The audio isn't that important. The visuals are.
You can just sing.
So this is Marcus Brown. He's one of my favorite video bloggers about technology. He's just testing 5G in the US. I wish I had that available at the moment. So that was 1.5 gigabits a second on a phone, which meant that like the Mercedes-Benz Stadium as a Trimble file compacted would load in roughly 2 to 3 seconds if our cloud infrastructure allows for it, which it should. We are running on AWS, Amazon services. So anyway, so what 5G gives us, decreased latency, so like the ping time between your phone or your laptop and the server, higher connection density because there has to be a lot of base stations. They need to be quite close to each other. A lot more traffic capacity, 100 times more, a bigger network efficiency. And one of the things it had, the impact on the industry, we can have cheap, not maybe embedded, I would say attached, because we don't want to embed it, we want to attach it to infrastructure. And because you can, on a single battery, if you're running 5G, you can run a sensor for 10 years or more. So, which means that you can have all kinds of sensors embedded everywhere. That's kind of the smart city concept. Which means that, of course, it has to be detailed then when you do your building and infrastructure models. So even more details into your designs. And so that increases the value of an exact constructible model. And you know where the sensors are, and you can utilize it for things like indoor positioning and so on. We can have real-time data transfer between field and office, and even things like real-time machine control, so like robotic workers, because of the low latency. This one so this is kind of from the 80s till where we are now. Here in the corner we have a ray traced image, and you can actually run ray tracing now in real time. The visualizer I talked about, one hidden feature that some of you who have used the visualizer might not be aware of is that we put a virtual reality mode into the visualizer. already in the spring. So if you press F8 and you have an Oculus or HTC Vive or a Windows Mixed Reality VR headset, there's actually a VR mode in there. So you can go from flat 3D into full 3D with the press of a key. Offline streamable high-quality point clouds. I actually showed you that demo already. And then one more thing, so large terrain and city models. And there was a question about that. And yes, we're doing things a bit differently. We are taking web technologies as well and putting them back on the desktop, like we did with point clouds. That was a web technology originally. Now we support it on desktop and mixed reality as well. And we are now doing the same with 3D tiles. So that's like when you want to have the whole globe available. That's a massive amount of data. So there's an open standard called Cesium and 3D tiles that we are now supporting with our desktop technology as well, which means that again you can place your model in context and work in context. A few words about machine learning. First of all, machine learning is not a silver bullet. It's not something you can just ask anything and then it will give you an answer. You will have to have very well-defined data and well-defined outputs, and then it can infer from previous data what it probably will be, and it's always a probability. It's not 100%, but it can be like 99.99 accuracy, and then it's usually good enough. So just kind of something to remember. But what can we do with this already? So automate repetitive task, production of drawings, so putting all the annotations in place, because every company has a bit of different way of doing the annotations so that they are understandable by the construction workers. Standardized detailing, putting rebars in place and so on. Scan to BIM, so object recognition from point clouds, for example. Computer vision, voice control. So actually that's an area where machine learning has led to the fact that computers are now better at recognizing voice than humans. That happened like 2 or 3 years ago. And then you can do real-time translation of language, which is especially in construction where you might have workers from multiple countries working on a big site. They can communicate in their own language and hear what the other people are talking in their own language. So again, makes communication a bit more seamless. Then a few words about mixed reality. So this is very old technology. It's like 500 years old, invented in Italy by an architect called Brunelleschi. So he used to mirror a picture and a pinhole in it. Trimble has been involved as well for quite some time. We have our first patents from the late 90s, but the hardware wasn't there. The idea and the dream was there, but the hardware wasn't really there. It actually started with 2014. We partnered with Microsoft with the HoloLens 1, and now in 2019, the HoloLens 2 and the Trimble XR10, where we basically brought the hard hat to the field and integrated it with the Microsoft HoloLens 2 hardware. So we have a group, and mixed reality for us is kind of, we think of it as like just another display technology now. It's just like you have to have web, mobile, and desktop, and we think also mixed reality. And it can be AR, VR, or mixed reality. So it's just part of our hardware solutions now. So a few words about the terms. So kind of one definition, virtual reality is then everything you see is virtual. There's nothing real in there. Augmented reality, then you are seeing the real world through like it can be glasses or it can be a mobile phone or a tablet augmented with some digital content. And the difference between AR and mixed reality is that in mixed reality, the virtual world is aware of the physical world. So I can attach holograms or content to physical objects and they stay in place. But otherwise, I mean, they are quite close to each other, but maybe not. And then a bit about the hardware. So mobile VR, the one device that I have with me, quite affordable for 400 or 500 euros, and full tracking, 4 cameras, controllers, hand gestures coming up, and you can actually connect it back to a cable to a powerful gaming laptop to use the visualizer, for example. So it's not just the basic BIM colors, but also shadows and the materials and so on that you can do. And one of the things that we kind of put in place now, like 2 weeks ago, was that we enabled web VR support in Trimble Connect Web when you have an Oculus or similar device. So now it's just a built-in feature. We are working also with high-end visualization, so this is more the future, although they are already out with their second generation product now. I was a startup 3 years ago. So we partnered with, or we've been working with Vario since 2017, and what they are doing, they solved the problem of virtual reality, the resolution problem, that you can see individual pixels because the screen is so close to you. But with Vario, because they are using 2 screens, the one in the middle is so exact that you cannot really tell the difference between real and virtual anymore. But they don't only want to do virtual reality, they also want to do extended reality. And here's an example of that.
With XR1, we are able to explore digital objects as natural extensions of the real world. Vario's vision is to create mixed reality where you cannot tell.
So if you think I'm crazy when I'm walking around with a VR headset, these guys are taking it to the next level. They are driving with one. Well, it has a pass-through camera, but then you get like, you can mix the real world and the virtual world, and you can't really tell the difference anymore. So a few words about the whole XR10. So kind of what you see is what you build. Basically, if you want to take mixed reality into a site or a construction site or a factory, you have to wear a helmet. So here's an example that we did together with Consolis already 2 years ago, I think. We were doing rebar assembly. I got 5 minutes of... So actually I worked in the construction industry for like 3 hours. I assembled together with my colleagues a 5.5 meter high column just based on a hologram and 5 minutes of training. And it was good enough that it passed quality inspection. So yeah, and we did it like very brutally. We just placed the hologram in place, no instructions, no sequencing. And even with that, we were able to assemble it. So that it's somewhere now in Sweden in a building, a column in some office. So that's me. Okay, one problem so how many of you have tried the HoloLens 1? A few? Okay. So one of the problems with the HoloLens 1 and like mobile hardware in general is that even though it's quite powerful with a mixed reality or VR experience, you need to have the picture drawn 60 times a second, which is quite a lot. And our models are quite big. So the Mercedes-Benz Stadium, the Super Bowl Stadium is one example. It was actually multiple Tekla models. And quite a nice project. So the roof structure is something that it has a retractable roof, so if it's raining, which it sometimes does in Atlanta, then you can just close the roof. A beautiful building. How do you get that to the HoloLens? With something called Azure Remote Rendering. So we partnered with Microsoft on this one as well, and we've taken capability from 500,000 polygons all the way to over hundreds of millions of polygons. And everything is rendered in the cloud and then streamed to the HoloLens. So this is a video from a couple of weeks ago from this same roof structure with over 200 million polygons in it. So hundreds of thousands of individual objects, all the bolts in place and running on HoloLens 2. So pretty cool, I think. Then Trimble Site Vision. So in cases where you are outdoors, the HoloLens is maybe not the solution because of sunlight. Not a problem in Finland most of the time, but I don't know. Here you have a bit more, you're a bit more south already. But typically, sensors don't work really well in direct sunlight, and also the holograms are kind of quite dim. So for that, we've developed something called, or Google and Apple have developed capabilities to run augmented reality in the browser on a mobile phone, and you can do exact tracking with that. But the problem is that when you walk for like let's say 50 meters, it's already off by half a meter in some direction. So with that, what we've done is we've combined exact positioning. So let's say plus minus 2 to 4 centimeter accuracy GPS antenna with augmented reality, so that we can actually see what's underground and what's above ground. So here's an example from Norway, but the civil side is using it heavily, where you can kind of visualize what's planned and then embed that with reality, and then you can change the transparency, so you can actually, this is reality, this is what is coming. But all of these videos will be made available, so you can kind of look at that later. So there's one more thing I want to talk to you about, and that's human-machine interfacing and robotics. So first of all, one of the problems, so what we want to solve with devices like the HoloLens is that you can get to your information with your hands free, because we still need to use tools, we need to climb, we need our hands for actual work until the robots are coming, but anyway. And then we need input. So one way of doing input is just like with controllers or with hand gestures, with voice. There are many ways of doing it, but they all have some problems. So the controllers, well, then you cannot use tools at all. And same thing with the gestures, that it kind of works nicely in a demo situation, but then when you have gloves on or you have a hammer and whatever you're using, then it's kind of really hard to do. And then, well, why don't you use voice? Well, in a factory, the noise levels might be so high that voice recognition doesn't work. So what we are looking at is kind of how to interface directly with your neural or signals. And we did a prototype last year where we were reading brain signals, so that you can just by looking in a model, it was a VR headset, and we had a model, and you could just look wherever it did eye tracking as well. Then you could look at the beam, and then you could just think, I want the properties of that, or I want to navigate there, or whatever. I want to hide that object, what's behind the wall. And it worked. And then, but it was still kind of quite large. It was more of a technology demo, what's possible in the future. What I'm wearing now is a neural interface, which has it has a gyroscope, so it knows the pose of my hand, and then I have trained it for some simple gestures, so I can actually kind of control a 3D experience just with my hand, and there's no camera, so the camera doesn't have to see it if I'm using hand tracking, so it can even be in my pocket, and I can kind of control a virtual experience. Now a few words about robotics. So this is kind of...
From science fiction to reality, robots are beginning to enter construction in a number of areas. From autonomous rovers that can increase the efficiency and detail of site inspections, to mechanical arms that automate highly repetitive tasks like bricklaying and tying rebar, the robotic revolution looks set to gather significant pace in 2019. While the credibility of robots on live construction sites has long been questioned, the last 12 months saw a number of real-world trials deliver their results, and the unveiling of some astonishing developments.
It's a bit slow, but
now taken seriously,
let's check the next one.
How best to integrate robots, the impact they will have,
exactly,
job
and no
roles,
injuries.
and the new skills that will be required as processes become automated. Building on this progress,
So that one could be a bit faster already.
Intelligence is also beginning to have an impact on construction.
Anyway, so the cool thing is, Boston Dynamics, they have solved a lot of the movement problems now and autonomy using machine learning actually. And we're actually working with them now. So this was something that was announced on Monday. we have been working on together with Boston Dynamics for a while already, integrating something called the Spot, which is this robotic cute dog. So it's kind of waking up here or putting itself into action. So what the Spot is, it's terrain agnostic, versatile, robust, so it can carry a payload of over 10 kilos, 15 kilos. It can walk on a job site, can walk upstairs, it can sense the environment, avoid obstacles, and so on. And it's robust, so it works outdoors in the rain and so on. And then you can mount stuff on top of it. So of course, we have mounted an X7 scanner, which is the latest one, which has auto-calibration, which means that we can go teach the dog to walk the site every day, do scans in different places, auto-calibrated, create a point cloud, push that in to connect, and automate the whole thing. And you see the colors are matching beautifully as well. So here's just an example of some images. So this is from our office in Westminster, where they were playing around with our new dog, and some images captured of that. And the goal here is basically to automate things like progress monitoring on a site. So this is actually from a PhD done at Cambridge some years ago by one of the rebar workers in the video, the lady. This was her PhD, how to use mixed reality to automate this progress tracking. So the things in green, they're okay. What's in yellow is being constructed, and if it's red, it's delayed.